Now second combination, that is the series combination. So in the series combination, the capacitors are connected end to end. So for example, if we have capacitance capacitor C1, then C2, then C3. In this combination, each capacitor's right place is connected to the left of the next capacitor. C2 right plate is connected to the C3 left plate of the C3, and finally we get this one last. Finally, the C1 left plate is connected to the positive terminal, and the C3 last capacitor right plate is connected to the battery negative terminal. So in this combination, so we need to find the total equivalent capacitance. So in order to find the total equivalent capacitance, we must remember that here in this case, if charge Q is flowing through the circuit, so that the total charge plus Q that is stored in this, that is same charge minus Q is also stored in this capacitor. So similarly, electrostatic induction says that this plus Q is also stored in this, and minus Q same amount of charge is stored in this, plus same Q is stored in this, and same minus Q is stored. So all the capacitors has same charges, all the capacitors stores the same charge. So charge does not divide in this case. So Q is equal to Q1 is equal to Q2 is equal to Q3. But we know that the potential of V1 is different between the V2 and V3. So the total potential is V1 plus V2 plus V3. Suppose that this battery has 100-volt potential, suppose 90 volt for example. If capacitance C1, C2, C3 are same, so 30 volt is divided between this, 30 volt divided between this C2 and 30 volt. So the total potential is divided equally among all the capacitors. But as we know that the potential is not same, the capacitance is not same for each capacitor. C1, C2, C3 are different. So the total potential formula is V is equal to V1 plus V2 plus V3. And now we can find because we know Q is equal to C1V, Q2 is equal to C2V, and Q3 is equal to C3V. So if we put V1 is equal to we find V1 is equal to Q over C1, V2 is equal to Q over C2, and V3 is equal to Q over C3. So now we are left with the this Q over C1 plus Q over C2 plus Q over C3, and the total capacitance is Q over C equivalent. So this Q will be cancelled because if you took the Q common, so Q will be cancelled. So we are left V1 over C1 is equal to 1 over C2 plus 1 over C3. So this is the total capacitance. 1 over C equivalent is equal to, or total equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Okay. So if we know the value of capacitance C1, C2, C3, we can find the total capacitance by using this formula. For example, if C1 is 2 microfarad, if C2 is also 3 microfarad, and C3 is again 2 microfarad. So we can find the capacitance, total capacitance, by using this formula. 1 over C equivalent is equal to 1 over 2 plus 1 over 3 plus 1 over 2. So we just solve 2, 3 to the 6. So 2, 3, 3, 2 plus 2, 3. So 6, 8 over 6. So 1 over C equivalent, that is equal to 8 over 6. So C equivalent is the 6 over 8 microfarad. So this is the total capacitance on this capacitor. Okay, thank you.